Aha! Test 1, 2. Oh my goodness. Everything was breaking, but I believe you should be able to hear me now. And I am just about to begin. There's probably a loud hum because it's very hot. I have a fan going. Let me know how irritating that fan is. Hello! Happy Coding Train live stream day. It is me, your host, Daniel Schiffman, with very, very dirty glasses. Let me see if I can clean these. It's very unlikely that this is going to do any good. Whew. It's a miracle that I am here broadcasting to you live at this very moment. It's a miracle if this is actually working and you are hearing and seeing me. I'm checking out the Discord chat. Simon says, I don't even hear the fan. That's good news. And in the YouTube chat, I see Frank says hello, and Dara Z says hello, and Radesh says hello, and Alex says hello. Whew. Okay. I was in a panic for like the last 20 minutes trying to get this stream together. I've upgraded my laptop, which is right here. My monitor is over here, which is why I keep looking over here. Unfortunately, my arm is cut off because my layout is all wonky. I'm in a transition phase for the Coding Train, and I have some announcements and information to impart. I also have some work to do on today's live stream, which is very important and involves coding. Let me briefly, before I forget, come over here and say a thank you to, and I totally messed this up, today's sponsor, Brilliant. Brilliant is a website and app. One of the things I'm going to come and look at some of their new lessons. There's a redesign of their course algorithm fundamentals, which is really exciting. I want to try some of it. But what they're really emphasizing and have done a lot of redesign of their courses is interactivity and interactive lessons. It's really fun. You know, I don't have my mug that I usually like to use, my geometry mug that I like to use to demonstrate static learning versus interactive learning. This is a Brooklyn Cyclones mug, the minor league team here in the plays out of Coney Island. But you can sign up for free. Check out Brilliant at brilliant.org/codingtrain. You can sign up for free if you want to unlock all of the courses. I'm going to show you some of them later. The first 200 people to sign up through that link will get 20% off. All right, so what are my announcements? I really meant to make a list, so I'm just going to have to rely on my own memory and wits, which has not been very reliable, if I'm being perfectly frank, these days. But I have some things to discuss. Number one, I think if I come back here, I have to press this button manually because I've messed up my Stream Deck where all my buttons work. Number one, are you familiar with the Coding Train website? It's where I collect all of the content that I have created over the years on the Coding Train YouTube channel. It is categorized into various a navigation bar. One of the things that's super important to me is to have this beginners tab where you can see like these are 3 tutorial sequences that you can start with no experience whatsoever for total beginners. There's a bunch of things organized here under learning. There are the coding challenges, which tend to be the more sort of popular videos of mine where I work on an individual project. This website is undergoing a complete and total redesign. And I am looking for you, the viewer of the Coding Train, to help with this redesign. In fact, we're looking for a few volunteers to do some alpha or beta testing. And Manthan says it's the best website ever. Oh boy, it's going to get so much better. But I'm looking for some volunteers in particular with a range, like somebody who's totally new to coding, maybe new to the Coding Train, somebody who's maybe been watching the videos for years and maybe has a lot of experience coding. Anyway, I'll be doing this recruiting if you want to participate in the sort of testing and feedback for the new website design in Discord. So what's Discord, you ask? Let me just switch over to this camera. I'm over here and I'm switching now to here. Okay, so let me make this a little bit bigger before I show it to you. And close this. Okay, now this is Discord. It is a chat system that you're likely familiar with if you spend any time in participating in online communities. Discord started, I believe, my understanding for gaming communities, but you know, I'm a member of different Discords for some podcasts I listen to, and there's a Coding Train Discord. There's a ML5JS Discord. Anyway, join the Discord. Follow the instructions in the README. Sign up for getting the notifications role, and soon Kobe, who is our Discord manager, the Coding Train Discord manager, I haven't actually let Kobe know about this. Email is forthcoming. Later today, we'll be making some announcements for how you can get involved in helping with the new website design. Okay, so I wanted to make that announcement. The goal is to have the new website by the end of the summer. The other thing I want to talk about, and this, you might not realize this, I don't even know if I realize this. This is something of a bit of a momentous occasion. Joseph asked me here in the chat, are you in New York City now? I saw some pretty scary videos of the hurricane. Hope everything's okay. So thank you, Joseph. I am fine. I am in New York City. I'm in Brooklyn. The hurricane, which was by the time it sort of wafted over the city, was, I think, downgraded to a tropical storm. It hit around like 5 a.m. this morning. I was sleeping. I sort of woke up. It was actually quite nice to have the sound of the rain because it wasn't that extreme of a storm, at least from what I could tell. And everything seems fine here. There was quite a bit of flooding, but I didn't really experience that where I am, and I hadn't really been going anywhere other than in my immediate neighborhood. So, but I have been, I think, for about the last year. Can't remember when I moved into the attic. I'm in an attic. Let's see if I can get this to work. Hold on a second. I'm going to show you what's going on and why I'm a little sad to report that there might be some light. Let's see if this works. Elgato camera. What's it called? The Epoch Cam. Let me see if I can add that. Add video capture device. Add existing Epoch Cam. There we go. Whoa, okay. Hi. So now I'm just live streaming from my phone, and I'm going to give you a little behind the scenes look here. Let's see if I can flip this over. And in fact, Okay, let me put this down for a second. This is my Stream Deck that I was fighting with. There's no reason for you to have to. Okay, hold on. What do I do here? This is impossible. Okay, there. Here's a little scene for you. This is live producing the show as I am recording the show. Here we go. Let me move this over to the side. This is me here. Where am I? I am. This should go down, I guess. So it's behind me. At some point it'll get behind me. There we go. So now I'm in front of it. I don't know how I feel about this. Let's move this over here. Better, much better. Okay. So, but now I can't point to it. I'm really obsessed with it. All right, it's fine. All right, so what you're seeing here is my console, which has Discord open, the YouTube chat, open broadcast studio. There's my random number book. I sort of keep track of like some stats on YouTube. Like you can see, there's 174 people watching. My numbers have been way down, by the way, which I think is mostly the fact that I'm completely inconsistent in my schedule and content. Here's my laptop over here, but I was going to show you very quickly. You can see this giant pile of boxes, also some Lego that I need to get working on over here. I am moving, and it is not necessarily a permanent move. But it is it involves not being in this attic anymore for the time being. I think this is my last stream from this attic. So I'm attempting to move and broadcast from a different location, which I will talk about in the future once it's sort of set up. But I am going to try to broadcast from a garage up in upstate, further upstate in New York. It's probably going to take me several weeks to get that set up. So I have a lot of content still that I'm working on in terms of video tutorials and things that will come out. I don't know why I've still got this camera here. And I will be back to Brooklyn also at some point in the nearish future, I think. It's all very complicated. If you want to, maybe this could be like a member bonus. I can do a member Q&A in the Discord about my complicated life planning for the next year. But it's just all very unsettled and it's a puzzle and the schedule is off. So I have to apologize in advance for what will probably be a period of no live streams. However, if all goes according to plan, and I've said this before with various moves and changes I've been shuffling around over the last few years, but if all goes according to plan, I'm going to have a very large space with new equipment. I mean, a lot of the existing equipment, but I'm also going to get some new equipment and hopefully be able to have a better experience for you of both video tutorials that are published on the Coding Train as well as regular live stream events. My holy grail, what I am trying to achieve, and Gareth asks, is that a Millennium Falcon? Wait, was that the Lego you're asking about? Oh no, it is the Death Star. It's Lego 75159, the Death Star. I have other questions to answer here. These are good questions from Abe and David. I will get to those questions. My goal, my holy grail, is to have a regular weekly time with an organized, structured schedule for my live streams. And we're going to see if I can make that happen. I have a feeling there's a good chance I'm going to be able to make that happen starting in January 2022. But if I can make that happen starting in September 2021, I will be very happy. Abe asks, why do I always wear the same hat? Well, first of all, I really need to get a new Orioles hat. This is a Baltimore Orioles. I grew up in Baltimore as a kid going to see the Orioles play at Memorial Stadium. I like to call Camden Yards in Baltimore the new stadium. And recently, even a few years ago, someone pointed out, it's not really the new stadium because it's been there for over 20 years. But when I was a kid, I was a big baseball fan. Baltimore Orioles were my team. They're still my team. I wear their hat. I like the color. I like the cartoon character. I like everything about it. So that's why I wear this hat. Oh, I did pronounce Abai. I'm not good. I apologize. It's very important to me to learn to pronounce people's names correctly. I feel like it's I don't know, rude or I was disrespectful. It's not very nice to like mispronounce people's names, especially if you've been corrected. And I try to really like learn my students' names in my NYU courses and pronounce their names correctly. And I really struggle with it, and I got it wrong again. So if I could get a reminder in the chat with the phonetic spelling, Mark Boots says we'll see, which is right. So David says, so I know you're having external people upgrade the site, but will it be open source eventually? So David, so the idea is for the site to remain open source and for it to continue to be a community maintained website. And actually, David, we can talk about this. Abai, thank you. Abai, thank you. Abai is who asked about the hat. But David, let's chat. Let's have a chat about it because I would love to loop you into more of the stuff because I know you've been such a kind and generous contributor to the coding train. Adriel Oliveira is in the chat. Adriel is a member of the coding train. I see Mark Boots. If anybody who is a member who hasn't gotten their stickers, the train whistles there's going to be lots more to come about that. Boy, am I just a broken record about the things that are to come. They really are. It's really happening. The progress is happening every week. Make sure that you're in touch, that you filled out the Google form, and that you're in the Discord members channel if you haven't. Okay. Peter says, thank you for everything you share since all these years. Amazingly, thank you, Peter. I'm wondering, it's very unlikely, but I met a viewer in, I was getting my car serviced. Actually, the air conditioning wasn't working. I had to get it repaired. And I met someone in the waiting area at the car repair place who said, oh, I watch your videos. And that was kind of amazing. All right. So Cora asks, would you want to go into P5 plus Bluetooth like the Arduino? There is a Bluetooth library for P5. I would recommend that you check it out. Maybe I can pull that up and take a look at it. All right. So I'm trying to think if there's any other news. Mark, why don't you, hopefully somebody can help you with that, but just tag me in a message after the stream is over and I will help onboard you with the Google form. Craig asks, any coding in this video? Yes. So I have been slowly but surely working on, and I'm going to pull it up right here. Whoops. If you've been watching any of my videos as of late, if I go to the coding train on YouTube and I go here to videos, you'll probably see that what's been released most recently are 5.1, Autonomous Steering Agents and Introduction, 5.2, Seeking a Target, and 5.3, Flee, Pursue, and Evade. The next video to come out is Arrive. Then I have a video that was recorded on the wander steering behavior and a video that was recorded on path following. So I make reference to this incessantly, but this quest that I'm on to complete a P5.js version of every single one of these steering behaviors and to stay as faithful as I can to the original implementation of these steering behaviors. Now, what I want to show you that's very exciting, and it's going to take me a minute to get this up and running here. Great, I'm already here, is that I have, I was able to get an older version of Java working and running on my computer so that I can run the original Craig Reynolds applets. Now, I wonder what year these were created. The paper was published, I believe, in 99. It's 1999. I hadn't even really I didn't know anything about coding then really at all. I mean, maybe I'd done a little bit here and there. I was an adult. I am apparently quite old to be on YouTube live streaming. Although I hope to be doing this for the long haul. I'm not going anywhere, people. This is my life's work. I keep thinking like, what do I want to do with my life as a 47-year-old human whose 48th birthday is coming up, by the way, in 20 days. Not that I'm asking anybody to get me anything or wish me a happy birthday, just noting that you know, in case anybody wants to keep track. So what was I talking about? I'm really, you know, one of my passions is kind of computer graphics history. It's why I like to focus on kind of topics like Perlin noise, particle systems, and looking at the origins and early implementations of some of these algorithms and techniques that we take for granted. And steering behaviors to me is probably you know, where I, you know, learning to program steering behaviors is probably where I really like fell in love with creative coding. Anyway, so you know, I have a whole chapter on this in the Nature of Code book. I implemented a bunch in processing. I'm redoing them. I'm updating. What I have learned, what I have really learned, is that a lot of the assumptions that I made, even reading the paper and trying to follow it and make what was I saying? I lost my train of thought, haha, because I'm also reading the chat while I'm speaking, which no one should ever do. Completely forgot what I was talking about. I'm talking about steering behaviors. You know, I diverged from quite a few of the techniques. I diverged and altered my implementations away from some of the way it's described in Craig Reynolds' original paper. So, and some things I did that you could, you know, perhaps make an argument as an improvement or a kind of way to simplify the algorithm to make it more approachable. But some you could also argue are like kind of egregious mistakes. And this last video that I published, Flee, Pursue, and Evade. Pursue is fine, but the way that I implemented flee and evade was quite off base. And one of the things that I really am trying to do more on the live stream is address feedback and comments. Whose birthday is it today? Fox the Bomb. Oh, your birthday was yesterday. Ronald writes, I've been working on Craig Reynolds' Boyd simulation Vanilla.js. Oh, that's cool. Would love to follow your work there. And I meant to, a practice that I want to get into is compiling a list of comments that I want to address and respond to from recent videos. And I did a good job of doing that last live stream, and I couldn't get it together for today. But I know, in fact, that there are some excellent comments here, and mostly I replied to them, I think, if I wanted to address them. So let's take a look at some of these. How do I find the comments if I zoom in here? Is it below all this? Yes. Okay. First of all, Mark Boots upgraded the membership to conductors. Mark, thank you for upgrading your membership to the coding train to conductors. I forget which level that is. I think that's the highest level. Oh my goodness. Well, this means that you will be receiving your very own custom laser-etched train whistle with a random walk pattern on it. Stay tuned. We'll chat about it in the Discord. Okay. Getting back to these comments. All right. Getting in early. Congratulations on finally finishing every steering behavior, and Happy New Year's 2033. Okay, let's see. 2033. How many years from now is that? Not too far away, if I'm being perfectly honest. Will I have completed? Place your bets now. I don't know if you can, if they're taking what the line is in Las Vegas at the moment. Engineer is the highest. Conductors is great though, in the middle. I can never remember. Thank you, Abai. I'm reading the chat is fascinating, and I really shouldn't read it while I'm talking. I want to address and participate in the conversation. And Brennan says you should check out David Fulmer's comment. Hopefully I will. We'll see what I get to. But anyway, we'll see. I don't know what the line is in Las Vegas. Will I get to all the behaviors by 2033? Place your bets. All right, that was my joke that I was in the middle of that I completely botched because I started reading the chat. All right, so let's look at this first comment from Nick Combs. Pursuit should probably check further ahead of the target's velocity based on the distance. The longer it takes you to catch up to something, the further it will have traveled. All right, so let's go look at the code, and let's see if we can actually make this improvement. So by the way, the main topic for today, I'll be here until about 2 p.m. Eastern. Hopefully I'll finish a little bit early. I have tickets to see Black Widow later. I'm very excited about that. Hopefully taking the kids. We're big Marvel fans in this household. I have my issues with Marvel. We don't need to get into that. This is not your cinema essay YouTube channel. It never will be, but I'm going here. Nature of code. Flee, pursue, evade. So every video on the coding train has a web page that goes along with it where you can find the video and you can find all the various code examples, the ones that I code in the video, as well as additional exercises that I often refer to or demonstrate. And so let's just look here at the pursue. I think I actually want to look at the pursue bouncing ball one to make this point. So what this is this vehicle is pursuing that pink dot. And when it reaches the pink dot disappears and reappears in another location, and the cycle repeats. So the target that it is pursuing, let's make a duplicate version of this. Excuse me. Let's call this live. I'm just going to, I don't know what to call this. Whatever. Live stream variation. I'll think of something better later. If I look at the vehicle, and I think I would like to see the debug information. So let's put that in. So, and that's very hard to see. I don't know why I did it that way. Okay, so we can see that what the vehicle is actually pursuing is the target, the green dot, because the idea of pursuit is what it's seeking. It's pursuing the pink dot. And why does it get stuck on the edge sometime? That's another thing I need to fix. It's pursuing the pink dot, which means it's seeking the green dot, which is a predicted future location. And the comment is check further ahead based of the target's velocity based on the distance. Wait, this is actually not what I thought this comment was. My understanding of this comment, and I think some other people wrote this as well. And I'm just peeking through the comments to see. Afraid of the target. Yes, this is what I'm looking for. TMC posted this. Pursuit should derive its estimated target position based on the distance the pursuer is from the target. Oh, this is even different than what I was saying. Wow, this is so interesting. So in my brain, what these comments that I was imagining I was going to find were that the distance of the green dot from the pink dot should be mapped to the speed of the pink dot, right? If it's moving faster, we might want to try to look further ahead to head it off. If it's moving slower, we could seek, I don't know what I'm saying we is, the vehicle could seek more the actual location of the dot. So, but now also, oh boy, is Coding Garden streaming? So I didn't, I wish that I had known that and planned better, because I definitely don't like to conflict with Coding Garden. But let me just give a plug to Coding Garden on Twitch. Everybody feel free to go watch the Coding Garden stream. You really want to. That's going to be much more productive and useful than this one. So I don't know if both comments are the same, but there are two things that there are several things at play here. One is the velocity. So let's just look at what I was thinking, which is, what if, well, first I want to fix this issue where it's getting stuck. So the target, okay. This is why. The target is reversing its position when it gets to the edge, but sometimes with, you know, a rounding error or whatever, it might not make its way all the way back on. And it should, we might have to slide it back to make sure it is exactly at the position it should be. So let's make this correction. And then we can do exactly the same, but with a Y and height, and exactly the same, but with Y. And to be consistent, I will put the position. So this is very long-winded. I'm sure this could be consolidated or written in a more elegant way. I always am saying that. The prediction could also take the bounces into account. Yeah, now that that is far too sophisticated for my little brain to handle right now. So one step at a time. But FW, that is an excellent comment. I love that. That I would love for somebody to go off and implement and tweet at me at Schiffman, or like share your own community contribution to this. If you implement that where it can actually like predict the bounces, oh, I would love to see that. That's really a cool idea. So every time it hits the edge, in addition to reversing its velocity, it also makes sure that it doesn't move past the edge. So that should fix that issue. All right, so now what I wanted to do was map a couple things. One is, let's see how crazy we can get about this. So where is the pursue function? Here it is. So right now, this number 12 is just hard-coded. So that is the look ahead value. Like for example, if I say let look ahead equal 12, let's make it equal to 50. And then I put it in here. We can see it's looking ahead 50 pixels. Now wait, that seems way more than 50 pixels. Oh, it is taking into account. So it's already, so first of all, way to read your code, Schiffman. It is already taking into account the vehicle's velocity. Because it is not the fixed look ahead, it's not a fixed look ahead distance. It's a look ahead factor, really. Based on the velocity, how many frames should it look ahead? So now I'm realizing, maybe I addressed that in the video, and I just didn't realize that I did that. All right, so let's put that back to 10. So I'm fine with that, I'm keeping that. Now I think there's another interesting aspect that was pointed out, and Chris is writing this in the chat right now. Green dot location should change based on both the pink velocity and the distance between your vessel and pink. Thank you, Chris, for putting that so eloquently. So let's look at another value here. Now, in the pursuit, it's too bad. What I wanted to say was somewhere in here, I'm probably getting that distance, but let's just look at it again. It's not that much math. It's not something for me to really worry about in this case. If I had 100,000 vehicles and 100,000 targets, I might start to really need to think about optimizing, but I think I'm okay, in the clear here. So distance is P5 vector dot distance between the target and I'm so confused. Oh, I'm pursuing the vehicle and this dot position. So that is that particular distance. So what if I just actually added that to, what if I have an idea. What if I said, so if I said prediction set mag that distance, and let's make the look ahead factor 1. So right now, You can see that. It's actually kind of cool to watch. The chat is saying target.pause, but it's actually just the target because the target is already a copy of the vehicle's position. But you can see now this is kind of cool. I really like this. As it gets closer, something's wrong here though. I mean, it really should also have to do with a comparison of, I guess that's just, or maybe that's just too much. So what if I then said this was 0 point, like just 20% of that. Okay, that's 50% of that. And the problem is when it's behind, I guess it's fine when it's behind it because it's going, yeah, this actually makes sense. And then what if I then had a look ahead factor also? Or do I want it based on the speed? So maybe what I don't want is, do I want to multiply it by the, I don't know. Yeah, Abai was, Abai has a great comment, which is, why did you make the target bounce off the edges? Why don't you add wraparound? Yeah, this is totally arbitrary. I just picked, like, I was just, in the video, I'm showing like a bunch of different things you could try. And so the bouncing here is definitely creating a bit of an odd behavior. Mark writes, the green dot represents how far the pink dot can look ahead. The pursuer can see much farther. That doesn't seem fair. Interesting, yeah. So again, what I'm trying to emphasize here, and I think I can stop, is that there's no right or wrong answer to this question. The idea of these steering behaviors is to creatively design the system according to what you feel makes sense for whatever it is you're building, or to just explore a bunch of different ways of trying it. So I could try multiplying these things together, I could add them together, I could take into account velocity of the vehicle, of the target, you know, all sorts of things. All of those things could be great things to add to the look ahead factor. But it's interesting to see, I like this behavior of seeing it kind of like shrink down as the vehicle gets closer. Okay. Let's see. I do want to take a look. Oh, look at this. And right here, Giulio made a community contribution. And this is the time on the coding train where I share the versions you made which improve upon and creatively twist the examples and various video tutorials and things that I'm doing here on the channel. So I'm so glad that this was submitted. Let's take a look at it. The better pursue algorithm prediction based on distance and speed of both target and pursuer. It's everything that I was just talking about. I hope this link works. Oh my goodness. This is wild. Oh, this is so fantastic. So we can see here, it's really like this very intelligent understanding of when exactly to meet it. Oh my goodness, this is so good. Oh, I thank you, internet, world of people watching the coding train, that I can just plant the seeds and this can flower. Oh, amazing. Let's take a look at the code. So first of all, we can see there's a nice little draw arrow function, which is cool to be able to see these things as arrows, not just as lines. This looks like it's the same, pretty similar technique to what I'm doing. Yep, this is all based on the code that I've written, so we should be able to just pop down here and look at this. Okay, here we go. This is the brilliance right here. There's a lot of stuff here. I'm going to try to make this wider so we can see the full code. Okay. Speed ratio. Let's try to unpack and understand this. And this is a great comment from Chris, who's talking about we could use an evolutionary technique to optimize which is a really, really wonderful idea. Okay, speed ratio. I'm going to try to understand this. Vehicle's speed divided by max speed. Okay. So how fast is it moving from 0 to 1 according to its maximum speed? That's great to always normalize your values so that it's going to help you tune the parameters. Such a smart thing. Oh, thank you. The coding, by the way, I have resigned from my position as host of the coding train. Giulio, if I'm pronouncing your name correctly, wherever you are, you're welcome to take over. I'm done. This is so good. Yeah, target angle, right? This is what I was saying. It's taking into account the angle of the approach. The angle between the vehicle's position and the target's position. Wow, the pursuer's and the target's position. Then take the sine of that angle times the speed ratio, and then I'm lost now. So I'm going to need help with this one. I need a whiteboard, which I don't have, and I also don't want to get too. I'm going to look at this a little more later. Maybe somebody can. David, please give my regards to Coding Garden. What's going on here? Take the sine of the angle, which would be the value of the adjacent, the length of the adjacent side. So that's like that's the distance. Okay, that's actually not so bad. The distance. Then shrink it by the speed ratio and then get the angle back. So basically it's the amount, it's like the arc length. I read it and I think I understand it. What's a good, I really need a whiteboarding solution for when I'm live streaming. The place where I'm moving my studio to, I'm going to have, I hope, a very good diagramming system, and I just don't have that right now. I don't know if anybody followed my sort of like talking through me reading this code and understanding, but I have a picture of what it's like in my head. I guess I could hook up a tablet or something and draw with my finger, but I'm going to move on. Then we get the distance, and the prediction is, now I'm lost again. The distance times sine of that angle divided by sine of pi minus my angle. Okay. Okay. So I definitely need my whiteboard. I need my diagram. But you can see here that what this is doing is it's taking into account multiple factors. Let's just look at it again, because it's really quite beautiful to watch. Like, that distance is not just related to like where it's supposed to seek is really relevant. Like if it is moving in parallel to it from behind or in front versus at a perpendicular angle, like where it's going to meet it is based on their relative locations as well as the speed that they're traveling. So, and Chris Sears, like, sine is opposite over hypotenuse. Yeah, why did I say adjacent? I don't know why I said adjacent, because I'm panicking and trying to do math in my head without drawing it while live streaming. Sorry to get that wrong. We'll edit this out of the live stream later. We'll dub this over. Chris saying this looks like the law of sines. So let's see if we can find a nice diagram of this. Speaking of why you should subscribe to... oh shoot, my button's not working. Brilliant. I have a feeling there's an interactive lesson to help understand this. But the law of sines is a sine rule relating the lengths of sides of triangles to the sines of its angles. Yeah. So we can see, I can imagine here that we've got kind of this big triangle where we have the vehicle's location, the pursuer's location, and we're trying to find, and then their velocity vectors, right? We're trying to find where the two shall meet. The seeking target. So this totally makes sense that you would use the law of sines, right? What if this is where the vehicle is? This is where the target is, and the target is moving in this direction. Well, based on its speed, we want to figure out what's the triangle. that's going to where they would meet, and based on its velocity and its velocity. And so if it was moving at a certain speed, and the vehicle is moving at a certain speed with a certain steering force, we could imagine that this could be the part it would want to steer towards here to meet this vehicle at the moment where it gets down here. So it makes a lot of sense that the law of sines would be happening here, and I would love to implement this in a video. I kind of almost want to like try to code it myself, but I have other things to cover today. I'm almost at the halfway point, and we have this beautiful, wonderful example. What a surprise to find this today. A train whistle for Julio, a bell for Julio. I mean, Julio should get a random number here for sure for this wonderful, this random number is in honor. This extra special random number is in honor of Julio and this amazing contribution to the pursuit steering behavior. And the random number is on page 211, row 10,515, column 0123, and it is 34,000. Oh, sorry, it's not a number, it's a sequence. It's a random sequence of 5 digits, 34764. There you go. Wonderful work. Thank you. Beautiful. All right, we're moving along now. Back to the comments. All right, fixed multiplier. We're looking at this. Now, I want to find the correction that Simon pointed out to me. And so let's see. I'm just going to scroll through these comments here. So it's about flee. I'm pretty sure somebody pointed it out. I thought I replied to it. Oh yeah. Why doesn't he have the target evade the pursuer? Yes. Why didn't I do that? So I'm definitely I'm gonna fix evade, and then I'm gonna do that. That'll be great. Let's do that. Okay. I'm looking for the comment that I'm looking for where I made a really big mistake in flee and evade. Interesting. I don't see the comment. Looking for it. By the way, this is amazing to me. I found your channel through Nebula. Not a sponsor for today's video. But a sponsor of the coding train. Wow, where does anybody see a comment that has the correction? I really don't think anybody would want to listen to a coding train podcast, although I appreciate the comment, Julian. I don't see it. I'm looking at the chat. I pointed out, I know, Simon, you pointed out in Discord, but it was brought up. I saw some YouTube comments about it for sure. Yes, here it is from Trevor. Long-time listener, first-time caller. Love that. Love this and you. Thank you. Always nice to have I have a nitpick question. I would say not a nitpick. This is a pretty significant error. And you can see that my reply is even incorrect, which I will unfold and show you how I got it wrong. In the move from seek to flee and pursue to evade, does it matter that it's the steering force that's being negated rather than the desired velocity? I don't have the paper in front of me, but I feel like the order of operations is not quite correct. You're absolutely right. So I want to correct this. Let's go look at the paper. Let's see if we can find and confirm. And again, I'm sorry that I don't have a diagram. Maybe I can share Simon's diagram, which is super helpful. I will pull that up in a moment. Let's look for flee. Yeah. So look at this. Actually, Simon's diagram is like this diagram. So first of all, I can even just see right now from the diagram, I did it incorrectly. And it upsets me so deeply because it also goes against the sort of core principle that I was emphasizing in these videos, where everything is derived from the desired velocity. And if you think about it, the desired velocity, the desired velocity for fleeing is to move in the opposite direction. And what I did is I just took, right, if this is the desired velocity, right? This is the current velocity. So the seek steering behavior is the desired vector minus the velocity vector. And you can see that here, and that makes sense. It's a vector that's going to push this triangle, cause it to steer and seek along the path to the target. So what I did for flee in a very lazy way is I just said, negate that. So the steering behavior is this way. And in truth, it's not so horrible. It's definitely going to move away from the target, because instead of turning this way, it's going to turn this way. But in truth, it's the actual flee steering behavior should be this one, because I should be looking at its desired velocity first and then taking desired minus the current velocity, which gives this red vector. So the flee steering path you can see is this red line. My guess, if I could draw on it, like maybe I could do it with my finger slightly, would be like, no, I can't because I'm tiny in the corner. I'd have to make myself really big, and I don't have an easy way of doing that. But I'll just do it with the mouse arrow. My guess is that if I do it my way, the path would be something like this, a mirror image of this path, which this is not a mirror image. It's a more extreme turn. And then Brennan is saying this multiple times, that there's a comment from David Fulmer, and so I'm going to go on. Yes, so here it is. Let me just heart this. So let's read this comment. It's a long one. I don't know if I usually don't, but let's. I believe the argument made by Trevor Sargent is correct. The desired velocity, not the force, should be flipped. Thank you. And it does make a big difference. Let's, I assume, upon further investigation during my live stream, it is most definitely not the same, and this is such an error that I plan to record a separate video about this correction. I'll do it on my TikTok. I don't have a TikTok. There's no TikTok. By the way, if anybody wants to be hired by the Coding Train to just make shorts out of my videos, we can figure out a way to do that. I would be open to that. I keep, YouTube just sends me message after message like, try our shorts, try our shorts, try our shorts. We're pushing shorts. Shorts are great. You should make shorts, shorts. I don't know. I can't do it. So where do I have my live stream open? Let's just put a link to it for future reference. I will get this video URL. If someone can reply with the time code after it's published, that would be great. Okay, so I'm replying here, and then David, thank you for this excellent. I haven't read over the whole thing. I'm kind of going on faith here, but I conceive. And actually, now I just jumped to the middle. It's why I don't like steering behaviors, because of how it should be done is so ambiguous that mistakes like this can be made easily. So it's interesting. I'm going to flip what you said. Maybe I'm just like the glasses half full, eternal optimist. But to me, your reasoning is exactly why I love steering behaviors, because I am saying this is a mistake, and it's a mistake in that I didn't follow Reynolds' instructions, so to speak. But I think there's no right or wrong answers here. It's about creatively exploring the possibility space. All right, so I'm just replying there. That's really terrific. So let's take a look at correcting that right now. And let me see if I can pull up Simon's diagram, which will also be super helpful. So I'm just going to go into the Discord. The reason why I'm just going to my camera here is I don't like to show people's messages without their sort of permission. So I'm just going to open the image. And then come back here. So this is a diagram that Simon made for me, which we can see. Basically, if this is the current velocity, and this is the, and this should say that this is the seek desired, and this is the flee desired. So this is not the seek force, this is not the flee force. This is the seek desired velocity, this is the flee desired velocity. Then this is the seek steering behavior, and mine did this red thing, which is obviously different than this particular. Now, it looks like it's so extremely different because of the length of this vector, but you have to remember that the length is capped at maximum force. So most likely, it's not going to be as extreme of a difference, but it is significant. Okay. So this is, and Kay is writing, I just want to, it's so lovely that Dan replies to comments on his videos. I don't know, maybe you're referring to me typing the comments, but to me, this is the greatest discovery ever of being able to use the live streams as reading through and going over and issuing corrections and seeing the creative, I mean, the whole point of what I'm doing is to build a community of people making this stuff. And as you can see, I'm not particularly, you know, I am not the expert, or I'm not I'm trying to like even use the words that I'm trying to say, but I'm not. I was gonna say like I was gonna say I'm not so good at this, but I don't want to say that because I don't want you to say that about yourself. So I don't want to model that behavior. We're all learning and figuring this out, and can't do it on your own. Is what I'm trying to emphasize. All right, so let me just go back to here. So let me fix this, and then I'll take a break. I'm just closing back the Discord. If anybody, I will post some links here. If anybody wants a link to this diagram, I will put that in the, so if you're in the Discord under live, schedule is where I try to keep people updated on the schedule. Links is where I post links to things because the YouTube chat is too ephemeral. Simon's diagram, and then code playing, let me just actually post, code playing around with pursue prediction distance. So that was, oh no, this is Julio's. Sorry, my watch is calling me. Where is this? Here we go. So I'll post this here so people can find it. And this is, let me go back here. This is amazing law of signs version. Okay, so those are all there for you in the Discord, in the live, in the links channel under the live category. Please come and say hi there. All right, now, what's next? So I want to do, evade, where was that one? Evade, wait, no. Well, I don't remember where the comment is. Stop calling me. Turn on my do not disturb. Do not disturb on. Okay. Where was the comment about the target? There, here we go. Okay. So I'm going to come back to this. Why doesn't he have the target evade the pursuer? It's my reaction upon reading this comment. Why didn't I do that? Why didn't I do that? Such a good idea. Let's do that. Okay. So is this the, oh, this is the amazing version. Well, do I dare? No, this is my version. This is not the amazing version. I'll use my crappy version. And then I should do it with, and I got to, I'm blocking the code here. I'll do it with my version. I should really do it with Julio's, because that would be cool to see. But let's just leave it at this. So, all right. So I've got a pursuer and I've got a target. And just for, where is the target? Class, vehicle. Oh no, they're both. I didn't use. I thought this was where I used. Okay, I need to go to evade. Oh, I gotta fix evade. I'm all turned around. Let's go to this page. Pursue, and let's look at evade. Evade. So this is true for both flee and evade. Oh boy. So evade, its desired velocity is to move away from its future location. Yeah, I don't know. Oh boy. Oh, this is freaking me out here. I think mine is more realistic. Yeah. Evasion. Hi, Dracula. Dracula is here. I'm a little bit terrified, to be honest. Dracula has a check mark, which I read as this is the verified real-life Dracula in the chat right now. Let's start with flee. I'll be working on wander when I come back from my break. Flee corrected. So this is flee. But okay. So where's flee? I'm realizing why I did this. Because it was so nice and easy. And why is there like a big, what is this? QR code. Oh, that's like because I forgot about my polls. Oh no. I'm so disorganized. I really do a terrible job at this. It's the worst. All right. Please. Go away. Okay. What's the font size here? It looks a little small. I guess it'll be fine. So you can see here my motivation for doing it this way, because I was able to just call seek and multiply it by -1. And now I think what I want to do is the following. I'm going to do it the same way you haven't seen this yet because I haven't published it, but I'm going to use a technique that I implemented with the arrive behavior. So I'm going to add a particular, a second optional argument with a default value of false. So this is the desired velocity, the vector that points between the target and the position at maximum speed. If flee, force multiply -1. So, and I'm calling it force the whole way through because that's ultimately what it is. But at this moment, it's the desired velocity. And then I subtract the velocity because I'm trying to use fewer vectors. I think I cover this in the videos. And then flee is just return seek the target true. So this is now very simple correction, but because I want to reuse the seek function, and I reuse the seek function for when I do arrive. What if I were to do this? Oh no, whoops. Because I'm realizing when I do arrive, I have a second modification. Right, and Harry points out, which is exactly what I'm trying to emphasize here, it depends on what you're going for. But I'm right now I'm trying to think of what's the clearest and least prone to error way. I probably should have some kind of like constant and enumerable or something like that. That's a coding thing, right? But we can see here, it's just obviously moving away from the target in a more extreme way. Okay, great. So that fixed that. That's fixing flee. I don't think Julio would mind. Let's go to, I want to see it with this creative version. Oh, I already, sorry, Rose, I already have a copy of it. So let me open that up. This is the Pursue. Oh, maybe I didn't. Maybe I didn't actually save a copy of it. Oh, and right there in the title, it says rule of signs. So I don't know why I couldn't see that. Oh, Simon has a really interesting idea. What if you make a modification of function itself? So I could pass in a function to calculate the desired velocity. I do like that. So I'm gonna maybe revisit that later because I want to just finish this off. Okay, so now what I'm looking at doing is the target. Is there an evade here? This is pursue. So in theory, evade, and I'm just going to totally copy paste it. Evade would be maybe I've bit off more than I can chew here. Where is the... Oh, because it's seeking the target. All right, I gotta look at Reynolds' paper here. Flee. Evasion. Pursuit is a moving character. It requires a prediction of the target's future position. The approach here, let me make it so you can see everything I'm reading. A linear velocity-based predictor corresponds to the assumption that the quarry will not turn during the prediction interval. T units of time in the future. Scaling velocity by t and adding that offset. Ideally, t would be time until interception, but that value is unknowable because the quarry can make arbitrary maneuvers. T should be assumed to be a constant, which, while naive, would produce better pursuit than simple seek. For reasonable ones, t should be larger when the pursuit is far from the quarry. All this is written in here, by the way. Problem is, like, I didn't reread the paper when re-recording these videos, which is clearly a mistake here. More sophisticated estimator can be obtained by taking into account the relative headings. So this is what Julio did. And now, evasion is analogous to pursuit, except that flee is used to steer away from the predicted future position of the target character. Optimal techniques for pursuit and evasion exist in the field of control theory. It's a reference to another paper. Versions here are intended to be lightweight and excuse me, non-optimal. Awesome. Those are my that's my love language. Lightweight and non-optimal. In natural systems, evasion is often intentionally non-optimal in order to be unpredictable, allowing it to foil predictive pursuit strategies. Wow, there's so much more to this. So I think what I'm going to do, oh, this actually is no biggie. Because evade is return seek the target evade, and in seek and this should really be flee. I don't like the way I'm doing this at all. So let's see here. So in theory, I now have a pursue algorithm and a evade algorithm, and the only thing different is I am reversing the desired velocity, not reversing the final steering behavior itself. And so now, what have I done here? Where is canvas? Then I should be able to go to here, and I should be able to see target edges, pursuer, steering. Okay, then I should be able to say target, let steering equal target dot evade pursuer target apply force let's call it evade force, let's call it pursue force. I spelled target wrong. Uh-oh. Do they immediately like, whoa, what did I do? What happened? Oh, I messed something up. What did I do? I totally messed up this algorithm. Wow, this is crazy what I did. It's kind of interesting. I think I'm just going to go back to my own version of it. Let's go back to my own version, which is evade. Let me correct evade. So the correction to flee was duplicate, evade, correction. If modification equals flee, then force multiply -1. Okay, so flee is seek, return this dot seek flee. Then pursue is pursue the vehicle, and evade is return pursue the vehicle with flee, So in other words, oh, and this is this dot pursue. So evade is pursue the vehicle, but passing in flee, so that when it returns seek, it does the flee modification. And flee is just doing seek with the flee modification. So then, so then I should be able to say, why is there an error here? Or a warning. Duplicate method evade. Because where did I put evade? Oh, right. So instead of doing this, this is my corrected evade. And let's see what happens here. If I run the sketch, it's evading it. So that's right. So pursuer evade, but I want pursuer to pursue. Okay. So this is now my unsophisticated pursuer pursuing the target. And what I want now is for my target to evade the pursuer. But why isn't the target moving around? Oh, you know what? No. Oh, of course. Let evasion target.apply force. I forgot that it doesn't apply the force. There we go. There we go. Now it's actually trying to evade it. There, I love this. Weird. Okay, wait a sec. That was very strange. That was very strange. Oh, because of the wraparound. Because of the wraparound, that's why I get into this weird oscillation thing. Maybe to make this look better, and apologies for my sort of like screen layout here, which is all wonky. Maybe to make this look better, I should have the vehicle has a maximum speed of 10, and let's make it a max. Let's make the vehicle let's set the maximum speed to 5 for the target. Yeah. So the target is much slower. The wraparound is really a problem. What if I have them both do the edges thing? Maybe that'll make it less weird. Yeah, this is kind of cool. So I wanted to get rid of the debugging because it's kind of distracting. It looks interesting, but it is distracting. And then I also would like them both to be triangles. Where'd they go? So let's see if I can make this full screen. Oh, is it not the hold on. This is this is where I'm going to stop. Window width, window height. I would really like to see them as different colors though. So can I do this? No, this is not going to work because it says the fill there. Oh yeah, I don't know why it did this, but it works somehow. One's green, one's pink. I don't fully understand why, but I won't question it. Okay, now almost ready to go to a break here. File, share, full screen. It's still doing that wonky edges thing. There we go. Finally seeing something kind of interesting. So what's a better way of doing this without the edges? I guess what I should do is put an edge force so they have to turn around instead of wrapping. Drunk paper airplanes. So I really kind of running out of time here. I'm way over where I meant to be. But I would love, let me post a link to this particular example. Let me exit full screen. And let me paste this into the Discord links. So what I think would really, really improve this, which I would suggest as an exercise to the viewer, would be to have a force from the walls that keeps them within the space. So instead of being able to like leave and disappear on the other side, it has to figure out how to like turn around and go back on. And then that might actually like feel like we have a much more, and Simon points out that the answer to this would be containment. So let's take a look at containment. This is, we can take a look at Reynolds. Well, this was, where is it? Why? Oh, there we go. Is it called containment here? Yeah, containment.html. Containment.html. Let's see what happens here. Right. So this is a really cool steering behaviors that keeps vehicles contained within a space. So this is one that I definitely need to do. And then if I made the borders walls that they were contained in, adding that to this would be the ultimate. Make a mental note. Somebody write that down. Remind me. Future live stream. Sunny, go back to work. Appreciate the nice comment in the chat. I am going to take a minute now to thank today's sponsor, which is Brilliant. All right, I have some exciting information to report about Brilliant, which is brand new. And, I have talked a lot, many a time, about Brilliant and about how it helps you to learn STEM. So, and the thing that I really try to emphasize, which is different about Brilliant from what I do on the coding train, is the fact that it is try it yourself interactive lessons. And Brilliant is always sending me updates about what they're doing with their platform, things that they've expanded, new courses that they've updated, and their update right over here talks about how interactivity is taken to a whole new level. So I'm going to show you a clip right now of one of their interactive lessons that is about the Pythagorean theorem. So you might remember from any of my videos what the formula for the Pythagorean theorem is, but the idea of this lesson is that by moving around triangles and actually proving that a squared plus b squared is equal to c squared, just through the interactivity of the lessons and your own manipulation stuff. So Brilliant, it's a website, an app, it's active problem solving, real time. Jump right into solving problems, coach bit by bit, and before you know it, you're going to have learned something totally new. So the other course that I really want to emphasize and show you is their algorithmic fundamentals course. So look at that. Does that not look like code to you? Right? So you don't need any coding experience, but if you want to learn about algorithms, the fundamentals of different algorithms, all the types of things that I talk about in various coding challenges and videos, with being able to sort of think through pseudocode and puzzle through it with interactive lessons, this is absolutely the course for you. So you can, if I come back to myself here, you can, let's actually just go look at, I think if I go to Brilliant, hopefully I'll be signed in, and I can go to courses. And I want to go to algorithmic fundamentals. Is that the one that it's called? Let me just look at my notes here about their course, new courses. Pre-algebra course is another one. Computer science algorithms is the link to it. So I think it is this one. That's computer science essentials. I'm going to go to computer science algorithms. Here it is. This is not one that I've gone through yet, but I'm going to hit start course, and let's look. I just want to see a little bit of this. So about learning algorithms. So let me move this over a little bit. Minimize this. Let's kind of go through the first lesson. Pseudocode. You're thinking about algorithms, prepare some food, traveling out of town, instructions for your hamster sitter. I can relate to this. I actually had to leave instructions for our cat sitter recently. No hamster. Check the hamster's food bowl. Look at this. All right, there are 4 pellets in the bowl. I didn't even look at the instructions. Check the hamster's food bowl. If the food bowl is empty, put 5 pellets in the bowl. Otherwise, if the bowl does have some leftover food in it, put 3 pellets in the pool. Okay. There are 4 pellets in the pool after your sitter follows instructions you gave them and before the hamsters have a chance to nibble on anything. They saw an empty bowl, right? No, we can't conclude anything. Because they could have had an empty bowl, put 5 in, and the hamster ate 1. Or there was some leftover food. I can't conclude. Incorrect. When the pet sitter is done, the number of pellets in the bowl can be expressed as the number of pellets in the bowl when the sitter arrived and the number of pellets added to the bowl due to the instructions. You can use the letter N to, by the way, this is like the kind of problem I'm trying to help my kids with in our math. We're kind of panicking doing this live. I got it wrong, which I want to say I did on purpose, even though I didn't, but the idea is to get the stuff wrong and puzzle through it. That's the best way to learn. You can use the letter N to represent the number of pellets in the bowl. If N is 0, there will be exactly 5. If N is positive, there will be 3 plus N pellets. So if there were 4, N is 1. 4 pellets if N is 1, that means the hamsters left 1 pellet in the bowl from the night before, so 3 more were added. That makes total sense. Okay, so you can get the idea of what it is like to do these lessons, again, just to see how they're interactive and you can start to manipulate the different elements and move them around. It's really wonderful. You can sign up for free at brilliant.org/codingtrain. I'm going to take just like a literal 2-minute break because I only have 15 minutes left and I want to talk about Wander. So I'm going to come back and I'm going to show you the Wander example and talk through it a little bit. But I'm going to take a 2-minute break. If you have nothing else to do in the 2 minutes, go to brilliant.org and /codingtrain. It's a way of supporting the Coding Train channel by signing up for free. And then, of course, if you're interested in unlocking all of the premium content, the first 200 people to do so will get a 20% discount. I'm going to take a 2-minute break to grab some water. I'll be back to demonstrate the Wander steering behavior in about 2 minutes and finish off for today. See you in a moment. All right, everybody. I took a very short break. It is 1:42. I have to be done at 2 p.m., which is about 20 minutes from now. I am off to take the kids to see Black Widow this afternoon. It is not raining outside. Maybe we can even get to the park. The weather has broken for the day, and the weekend is coming. So, what is next in terms of like what I have time for today? So what I did yesterday, and thank you again to Brilliant for being the sponsor of today's coding train. What I did yesterday, so one of the benefits of signing up for membership, the join button on YouTube for Coding Train, is when I record the tutorial videos, I will kind of simulcast them to members who want to sort of like put it on in the background, because it takes me a long time to repeat stuff and figure stuff out. So if you want to get a peek into that, you can. And what I did one of those sessions yesterday, and I recorded a video tutorial about the wander steering behavior. And so I'm showing to you up here in the right, again, this is the original Java applet of Craig Reynolds' wander behavior. It's quite a strange one. I talk about this in the video, but one of the things that I love about it is it really does emphasize the sort of creative thinking of these kinds of steering behaviors. Like, this is such a made up, weird system, but it works quite well, right? The idea of wandering is to have random motion, but to not have twitchy motion where you're just changing directions all the time, but to sort of stay moving in one direction for a while and then move in the other direction. And the way that Reynolds accomplishes this is by fixing essentially the steering force to the a perimeter of a circle projected out in front of the vehicle. So you can see here in the diagram, this is the steering force in red, and the steering force changes here and there, but tends to, if it's fixed to this circular path, it'll move to the left for a while, and you get these kind of nice wandering paths. And you can see here in my implementation, which I will start it over. And let me actually give it a slightly, I just want to be able you to be able to see all the code and everything. So let's just make this 600 by 600. And I think, yeah, there we go. So you can see here, this is my wandering vehicle. So the nice thing about this algorithm is this is good for scenarios, and I'll go back to Reynolds' paper here. Whoops. If you think of something like forage, so imagine you want to have a creature wandering a space, but if it gets near and sort of smells a bit of food, it will then seek that food and eat it and then go back to wandering. So you can use kind of wandering, I think, in different simulations as kind of like a default behavior that a particular agent will always go back to. So you can see this is the implementation. I go through this whole thing in the video, which will hopefully be published eventually in the next week or two. You might also be thinking that another way to implement wander would be to use Perl and noise. So again, these are made up techniques. I'm encouraging people to invent their own algorithm for wandering and submit it, which you'll be able to do once I publish the video. But I did do something in my wander, which is slightly different from Reynolds' technique. And I'm going to point that out here. It's this. So this is this. If this here is the point, I'll call it the sort of wander point, the steering point, the point to which the steering force is calculated. What I do is I look at this angle, call this angle theta. I move this point by a random angular displacement to the counterclockwise or clockwise, and we can see this in the code. And boy, there's no way I'm going to be able to get this done in 15 minutes. But we can see this code. We can see this in the code right here. Whoops. Thank you very much for showing me my notifications that I don't want to see. Right? Displace range is 0.3. I changed that wander angle by some random amount. So, and let's put all the debugging information back in. And, oh, wait, hold on. I'm going to duplicate this. Wander variation, I'll just call it for right now. I want to put the debugging information back in so you can see that. And obviously there'd be a more elegant way to have a separate debug draw function or something instead of just commenting it in and out. And we can see there, that's all the debug information. You can see how that point to which it's steering is moving through random displacement. So I personally feel that this is pretty much the same. Admittedly, my mistake in not following flee precisely was quite a significant error. Or significant difference. I shouldn't say error because there's different ways to approach it. This to me, and I think I should also just to work this out, let's not draw the path anymore. That by implementing it closer to how Reynolds describes it will make a less significant difference. But let's do that nonetheless. So what's different about it? So Reynolds writes that the random displacement is a vector displacement. Constrained steering force. The sum is constrained to the surface's sphere. Yeah. So this here, if I'm going to move this point instead of by a fixed angle, I'm going to move it by displace it to any point away at a fixed radial distance. And then if I move it to here, I will constrain it back to the surface. He says sphere because you could do this in 3D. That's actually one of the things I wanted to accomplish today, was to try to make a 3D version of this. Clearly, I do not have time for that. Next live stream or whenever I have some time. So I think what I want to do, maybe this is not that interesting to look at in today's live stream, but I've got 10 minutes left. Let's see how far I get. I think what I want to do is, instead of keeping track of this wander theta, I want to keep track of the wander point. And the wander point is going to be a vector. And I'm just going to initialize it at 0. And I call something wander point here. So I'm a little bit, I feel like it's actually fine because this is the low, but that'll be so confusing. Let's call this, let's call this force. This is actually going to be the force all along. So I'm going to change all of this. This is a little bit awkward what I'm doing, but I think it's going to make sense. Force, right? And now actually, force. Okay. What am I missing now? Wander point is not defined. Where did I forget to replace it? Here. Force. Where else? Vehicle wander. Okay. There we go. Force. There we go. Okay. So I'm back to what I had before. However, I don't want to have this idea of an angle. I just want to, I'm just going to make this 0 for right now. Okay, so if it's 0, it's always moving forward. So the wander point, I guess I need an initial wander point. And this is weird. This dot wander point equals, all right, so I need, this is, there's some hard-coded stuff in here, like this 150. So I think I need these to be, this is wander distance, is 100, and this wander radius is 50. So this should be this wander distance, and this should be this wander radius, this wander radius, this wander radius. Okay, I just want to get what I had before. So now, this is a little bit weird what I'm doing, especially because I haven't explained the full wander algorithm. So apologies for those of you that the video is not out yet. So thank you for tuning in and kind of following this part along. Probably just trying to do it in 3D would have been the more interesting choice for my last 8 minutes here, but let's see, I'm going to plow forward here. So the wander point should actually be a vector that's equal to P5 vector this dot position. Its initial wander point is adding its position okay, sorry. The wander point, let's make a copy of the velocity, right? It has an initial velocity, normalize it, and set its magnitude, okay, or no, and set its magnitude to the wander distance and the wander radius. Right? So the initial wander point, and then this dot wander point, add its position. So I just want to start the initial wander point at that green dot. Okay? So, and in that sense, I don't need to figure out where it is. Like, what if I just said for a moment, force equals wander point copy. This dot wander point copy. Because I'm starting, whoop, nope. Oh, it's not, because it has to be relative. It's relative to the... Oh, this is harder than I thought. But I like where I'm starting here, which is that the wander point, the first time, is... Like if I just do no loop, and... if I take why is there an error here? Force was used before. Oh. We draw the debug stuff. Okay, that's right. But I'm missing the one more circle, which is fine, which is this one. Okay. There we go. Oh, no. The wander point is... Oh. Oh, this is, by the way, I should just warn everybody, this is a failure. I'm not going to be able to finish this right now. And I don't even know if the way that I started this. The thing is, I'm trying to start with the point rather than an angle. And I'm realizing that I missed an interim step here, which is fine. I really like the way that I did it. It's so much easier to deal with the angle. This is like a crazy thing that I'm doing here, because I'm going to have to think through. I don't think starting with I guess I could go with the angle, then offset the point. I could probably use like a Gaussian distribution of changing an angular offset. I think the way that I did it is just frankly a better way of doing it. Somebody should prove me wrong here. Let's try this in 3D. I have 2 minutes left. Let me answer your questions. Okay, I'm gonna have to. So I would love for somebody to help contribute to this. This is the end of the stream. I obviously didn't get very far with this. Trying to think of what else is coming. I could use rotate to rotate it. Oh, that's a really smart point. But I don't really need to. I need a pencil and paper here, because what I need to do, and I should read some random numbers, but is maybe I can. I don't have my diagram. I gotta go set up my new studio. Okay, I'm gonna work it. I'm gonna okay, great. I've got a great question. So I'm gonna investigate this some more. The video will come out. You will think about it. I'll paste this into the Discord because I clearly went off the rails here. But if you want to start to wander variation, I'll put this here into the Discord. Maria asked a wonderful question, which is, hey, what is a Gaussian distribution? I've heard it on sound design, but not in animation. So good news for you. A Gaussian are often referred to as normal distribution. I do have a video about this. Let's see what happens if I search for it. It's a pretty old one from 2015, where I do go through. Interesting how it has like time codes. I don't believe I've gone back and time coded these. So these are like automated. You could look at this video, but better yet, think if I go to natureofcode.com and go to the introduction, we can see here the idea of a Gaussian distribution of random numbers is not a boy, it's been a long 2 hours. I don't know about you, but I'm exhausted and my brain is melting. But I'm going to demonstrate it this way. Good news for myself is that I'm pretty sure I have, a nice. So if I were, this is a great visual demonstration. If I were to pick a random X position every frame, just using random, the random function between 0 and the width of a canvas, I would see an even distribution. I would be just as likely to pick 0 as I would be likely to pick width, as width divided by 2, as 25, as 50. This is not how numbers usually appear distributed in things you find in nature. For human being heights are a good, sort of like classic example of this. There's an average height of all humans, and if you pick a random human from a room of humans, most people their height will be near that average or near that mean, and there will be fewer outliers. That's a normal or Gaussian distribution. It's often graphed as a bell curve. So if there is, if almost everybody is the same height, you can see there's a very big peak graphing that distribution. You could have a wider distribution as with more outliers. And in P5, I believe, if I were to just do exactly what I just said, like if I were to say let x equals random with circle x 200, 100, or 20, fill 255, 10. We would see here, and let's make this 50. We would see here that I'm filling up, evenly picking random numbers. It would be great for me to actually like pile them, and we'd see these piles piling up evenly. Because if I then did it with a Gaussian distribution, we would see the pile up happening in the middle. But I can change that by saying, let x equal random. I believe this is built into P5. I can give it a mean, which is width divided by 2. So that is now the average. You could see like all of the numbers are basically right around the average. Like in theory, any number could be picked and eventually given infinite time, we would fill up some of the outliers. But what we're looking for is what is the standard deviation? What is on average how far things deviate from the mean? And if I do a standard deviation of like 50, now we're going to start to see that there is a bit more of a spread, but still that cluster is mostly around the mean. So here's like a standard deviation of 10. And again, this isn't the best visual. I would encourage you to think about how you might visually demonstrate this. Drawing a bell curve would be the sort of classic way of doing it. Paint splatter is a kind of example that I often give. Could you use this to create a paint scatter? And Carlovan is saying, don't forget the kids. I definitely have to go. I'm going to put on my goodbye song. Turn the volume down a little bit, see if there's any more questions. This is the end of today's live stream. And Prathamesh says, why did I think you're moving to the East Coast for your sabbatical? So first of all, I already live on the East Coast. I talked about this more during the beginning of the live stream. Maybe that's where you are. I will answer all your questions about my moving plans in Discord. Everybody join the Discord. Don't forget, big thank you to today's sponsor, Brilliant. You can sign up for free at brilliant.org/codingtrain, or to get a 20% discount if you want to unlock all of their courses and premium content. What else do I want to say? Stay tuned. So more videos are coming out. There are 5 videos that I've recorded that are yet to be published on the channel. So stuff is coming out in the next month. I would be surprised if there was another live stream before August. But if I can get moved, get a new studio set up, I'll definitely be doing some test streams for members. So if you were thinking about joining, now could be a time to do that. Hopefully I'll be back in full steam, full force in August. Interesting, Maria, talking about a bell curve over EQs. That's great. Thank you for this feedback. That's wonderful to hear about. Rainbow Skeppy is telling me that I don't need semicolons in JavaScript. This is absolutely true. I am, amongst my many flaws as a human, I am a semicolons person. I can't give it up. August 20th, the weekend of August 20th, 20th anniversary of processing Java. I'm going to do something special on the coding train that weekend. Stay tuned. We'll see what that is. Really appreciate all of your comments and sharing of the videos, and I love it when people tell me about what they're watching and making on Twitter. Please join the Discord. Comment in the Discord. Come back. I'm trying to reach a certain threshold where I can get Discord partnership, but I need to retain membership. So stay tuned. There's the Discord moderation team is running some events and things here. Adrian also likes semicolons. Thank you, Adrian. We were one and the same. But you know, I have no judgment. This is a judgment-free zone. Semicolons, no semicolons, some no semicolons. All is welcome and allowed on the coding train. Thanks, everybody. See you probably not until August, but sign up for that notifications roll. I will keep you all updated and posted on my schedule, and I hope to be back with you soon. All right? Goodbye, everybody. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot, son. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot, son. This dot, this dot, this dot. Never forget this dot. this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody could. I'm gonna say once again, here we go, sing it with me. It's the polar Cartesian coordinate song. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. Sing it with me. It's the polar to Cartesian coordinate song. 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 Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind. Okay, let's do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens. Kittens and 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 kittens and kittens and kittens. I feel just sort of like a nice feeling of relaxation. Everything's going to be okay today. Dream is not broken. It has not frozen. This is a wonderful thing. Okay, we're going to do it. I'm really getting to something. I need my sound effect. Unicorns and rainbows and cupcakes. What else is there? Unicorns and rainbows and cupcakes. That was invalid syntax. I forgot. There was one other thing here that I think is important that I will use continuously over and over again in all sorts of text generation analysis things that I will use continuously over and over again. First thing I need to do is, yes, kittens. Kittens, kittens. I'm really losing my mind. Okay, we're gonna do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens and Das Vidania. Goodbye, Attic Studio. It was nice being here. Next time I'm back here, I don't know. I might come back here again. We'll see. Bye, everybody. Thanks for tuning in.